Hello class, welcome to this video on lesson 5.6 review for probability and statistics. Let's go ahead and go over these problem sets. So this lesson is about probabilities of independent events, multiplication rule for independent events. So number one, a string of Christmas lights contains 20 lights. The lights are wired in series so that if any light fails, the whole string will go dark. Each light has probability of 98% chance of working for a 3-year period. The lights fail independently of one another. Find the probability that the string of lights will remain bright for 3 years. So for this particular lesson, we have the idea that the probability of A and B is the probability of A times the probability of B. As long as they're independent, we can just multiply those probabilities. So here we have 20 lights, and so really we have so the probability that all 20 lights remain. That means remains and so bright and bright. So let's just say remain bright. So that means the probability that they're bright times the probability that the next one's bright times the probability that the one after that is bright. And so really it's just 0.98 20 times to the 20th power. Okay, we got here 0.98 to the 20th power. 0.6676. All right, so 67% chance. All right, in baseball, a perfect game is when a pitcher doesn't allow any hitters to reach base in all 9 innings. It says, historically, pitchers throw a perfect inning where no hitters reach base about 40% of the time. So to throw a perfect game, a pitcher must have 9 perfect innings in a row. Find the probability that a pitcher throws 9 perfect innings in a row, assuming that the pitcher's performance in any one inning is independent of his performance in other ratings. Okay, so we're doing the probability that his first inning is perfect, then the second inning is perfect, and so on and so forth 9 times. All right, so here it's the probability all 9 innings are perfect. So perfect and perfect and perfect and perfect all 9 times. So it says 40% of the time. So 0.40 raised to the 9th power. Okay, so we got 0.0003. So a really low chance for that to happen. All right, and then I think if you include more decimals, it's 0.000262. But you can just round it; it's fine. All right, so number 3. From experience, we know that a certain lie detector will show a positive reading, indicating a lie 10% of the time when a person is telling the truth. So it'll say that they lied 10% of the time when they're telling a truth. It says indicating a lie 10% of the time when a person is telling the truth. Okay, that means it'll say 90% of the time that they're lying when they're actually lying. Okay, so suppose that a random sample of 5 suspects is subjected to a lie detector test. Find the probability of observing no positive readings. Okay, so 10% is, it says 10% that they show a positive reading. So that means 90% that they show no positive reading, right? So 1 minus 0.10 equals 0.90 for no positive reading for one individual, right? So now we're doing this for 5 people. So, and so in other words, it says 5 people. Yeah, random sample of 5 suspects. So in that case, it's going to be 0.90 5 times. All right, so that's going to be 0.5905. And so this is the probability of not positive and not positive 5 times, right? So I'm going to say the probability not positive for all 5 suspects. All right, so number 4, an airline estimates that the probability of randomly selected call to its reservation phone line results in a reservation being made is 0.31. Find the probability that none of the 4, of the 4 selected calls to the phone line results in a reservation. So that means the probability of no reservation made, right? For one call is 1 minus 0.31. So 69% of the time you make a call, it's going to, result in a reservation being made. 31% of the time, no. That's for one phone call. But now it's saying none of the 4. So none of the 4. So that means it's going to be 0.69 raised to the 4th power. That's going to be 0.227. All right, so let's look at number 2. So people with type O negative blood are universal donors. Any patient can receive a transfusion of O negative blood. Only 7.2% of the population, American population, has O negative blood. If we choose 10 Americans at random, what is the probability that at least one of them has O negative blood? Okay. All right, so we got the probability of at least one with O negative. The opposite of that is to have no people with O negative. So nobody has O negative. That's the opposite, okay? So if we find that, then we can just subtract that from 1. So the 1 minus the probability that neither of the 10 have O negative. Okay, so we need to find that. So the probability of no O negative for one person is 1 minus 0.072, which is 0.928. Okay, so that's for one individual. And so now you want to do this for 10 people, right? So if you want to do this for 10 people, then you're going to do 0.928, right? So the probability no O negative for 10 people. All right, so that means neither of them have O negative. So I guess I should do that. I can say that. The probability neither of 10 have O negative is 0.928 to the 10th power. Okay, and so to do this final answer, right, we would have to do equals 1 minus that. And that will give us, so in fact, I'm going to actually find that answer. So what's 0.928 to the 10th power? So that's going to be 0.474, around there. And then, now we can go to this answer, which is probability at least one with O negative. Let's just say at least one with O negative. Is 1 minus 0.474, which is 0.526. So it's around there. Okay, then number 2, if you buy one ticket in Canada's lottery game, the probability that you'll win a prize is 0.15. Given the nature of lotteries, the probability of winning is independent from one drawing to the next. If you buy one ticket for each of 5 consecutive drawings, what is the probability that you will win at least one prize? So at least one. So again, the probability of at least one win, at least one prize, is 1 minus the probability of no prizes out of 5. Okay, at least one prize out of 5. The opposite of that is no prizes out of 5, and then subtract that from 1. Okay, so what's the probability of no prize for one drawing? Well, okay, well the prize for the probability that you'll win a prize for one drawing is 0.15, so it's got to be 1 minus 0.15, right? So it's got to be 0.85% chance that you'll lose on one drawing. And then the probability of no prizes out of 5, right? So no prize and no prize and no prize is 0.85 to the 5th power, which is 0.85 to the 5th power. Is it 0.44? Let me see. I'm gonna double check that. Yeah, so 0.444. And then we can plug it into here. So do 1 minus that to get our final answer. Equals 0.576. Or no, 556, I'm sorry. 556. This one's 526 and that one's 556. Interesting, the numbers. All right, so number 3, suppose that you roll a fair 6-sided die 10 times. What's the probability that you get at least 1 6? Okay, so the probability, okay, so let's go to the bottom. The probability of at least 1 6 out of 10 times, right? Well, the opposite of that is probability of no 6s out of 10 times, right? And so let's do that. So what's the probability of no 6 in 1 time? Well, that's going to be one. That's going to be if you don't want to get a 6, then that's 5 out of 6 chance, right? And so then the probability of no 6 in no 6s out of 10 times is 5 6 to the 10th power. Okay, so that's going to be 0.1615, around there. And then we can plug that into there. That's 0.8385. So there's a pretty good chance that none, or at least one, you get at least 1 6 out of those 10 times. Okay, all right, so now the next one, a shipping company claims that 90% of its shipments arrive on time. Suppose this claim is true. Okay, let me zoom out a little bit. Okay, says 90% of its shipments arrive on time. Suppose this claim is true. If we take a random sample of 20 shipments made by the company, what's the probability at least one of them arrives late? Okay, so the probability at least one late out of 20. Okay, at least one late out of 20. The opposite of that is 1 minus probability that none are late out of 20. Okay, so what's the probability that it's not late out of 1 for one past shipment for one? So for one shipment, well, the probability that it's late is 1 minus, or that it's not late, meaning it arrives on time, is 0.90. Okay, so that basically they already told us that. And so then the probability that it's not late for 20 of them, right? Let me just do for 20 here, just so that it's, so for that, just to keep it consistent. Okay. So then not late for 20, then it's 0.90 to the 20th power, which is 0.1216. Okay, and then the probability of least stat, just plug that in here. So 1 minus 0.1216 equals 0.784. All right, that's going to do it for the video, guys. I hope you found this useful and informative, and as usual, I'll see you in the next one.